All righty, let's see. Yep, up and running. Put a few things on the board here. Get a full screen first off. That's a little better. So this is not a deep dive into trig, but it is a video that I hope will help students understand radian measurements, which is a big part of the language of trigonometry. My experience as a teacher has been that when students have finished their pre-cal, which means they've had a unit in trigonometry, that when I ask them what a radian is, I often, more times than not, don't get a coherent answer. So I think it's important that before students get to a formal study of trig, that some of the language of trig needs to be presented. So they have a chance to start to process a major topic for a longer period of time. And the only way to make that happen is to start the conversation. Now, if you haven't seen the video, what is a radian? I highly encourage you to do so before watching this video. I just look on the channel somewhere, type in what is a radian. It'll pop up. All right. All right. So we're going to use the unit circle. We are going to approximate. And I've already put some good approximations from Google for the questions that I'm going to ask on the board. I made my guesses before I looked at Google, type things in the query bar, whatever you call it. And I was happy with my guesses. So I think I've got a fairly good feeling for radian measurement. And we'll find out if we can strengthen your understanding of that. Right? We'll start the conversation now. So we draw a circle. We start over here at 0 degrees. We go all the way around. We come back to 360. But we're also traveling along the circumference of the circle. And therefore, it doesn't matter the size of the circle. If we make it a 1 unit radius, doesn't matter, 1 unit, doesn't matter the size of the circle. So we start drawing triangles. Right triangles for starters. Well, that looks familiar to you as a degree symbol, I think. But it's also what? It's also part of the circumference of the circle. And matching up distance to distance, right? Distance is really what you're doing on the circumference of the circle. Matching that up number to number is easier than matching something up number to angle, because this is a two-step function tree. I give you an angle, you give me a ratio. All right, getting ahead of myself here. Purpose of this is to find out where different radian measurements land on the unit circle. And 0, 1, 1, 0, 0, -1, -1, 0. We've got some frames of reference. So I'll ask you to give me the x and the y coordinates in the unit circle, which corresponds to this language, cosine A, sine A, corresponds to that. Where would you land if I gave you 12 radians? Well, we got to look at the circumference formula, 2 pi r, and we're making r equal 1. So we have 2 pi radius lengths. Whatever the size of the circle, there's a radius length. And if we attach it beginning here, that should be about 1 radian length, somewhere in here. And over here would be, 2. I should have a string or something, right, to do a better job. And over here would be 3. And I hope you're anticipating 3.14. So if that's 3.14, 1 radian is about here. What radian measurement would be here? About 1.57. That's half of 3.14. And if I tack on 1.57 here, 6771, I get, well, let's see, 4.71 radius lengths to get me to that location on the circumference of the circle, and all the way around 6.28. I'm going to do a calculation for you in a few moments over there. So where's 12? Oh, that's a tough one, actually, because 6.28 double. 6.28 double is 5, excuse me. 6.28, I shouldn't have to do this. 12.56. Well, that's how much further is 12.56, or how far is 12 from 12.56? 0.56 units, little more than half a radius length. So I go around 6.28, 12.56. I come back about a half of a radius length. All right, and we are, now I'm lost track of where I am up there. 0.56 maybe a little bit more. But what can we say? Well, this is a half, right? This is 1. So I don't know. I think I'm, well, it's a good guess, drawing it over and down. So let's go right. I don't know. Did I type that one in? 714. No, I didn't do that one. I got to actually check that. So you make your guess. You can do just type cosine of 12 and sine of 12. It should recognize that as a radian measurement. You know, just type it in Google. It'll give you this coordinate. And I'm thinking 0.56. Taking too much time here. So I'm gonna forego that one right now. I'm guessing maybe 0.7, maybe somewhere in there. And it looks like it's near -1/2. Rough guesses. I didn't spend any time on the sine of 12 and the cosine of 12, so I don't know why I asked that one first. I did spend time on 14, the cosine of 14 and the sine of 14. So again, we're at what? 12.56. We got to get to 14. We're at 12.56. We got to get to 14. We got to go another 1.44 radians. And I know this is 1.57. And it's pretty flat here. Pretty flat. So I got a feeling that, you know, I was saying it's almost a straight line at the top of the circle. So I was guessing around 0.13. I just subtracted 1.57 and 1.4, or whatever I said, 4. And we're almost at the top here. You know, I'm thinking we're probably right about there. So 0.98, 0.99, something like that, because we're almost all the way up to 1. It turns out it was 0.136. This was 0.136 as an x distance. And it was actually 0.99 rounded off to the second decimal place. Yeah, we're almost all the way up to a height of 1. How about I give you the -3 for a radian measurement, and you can kind of guess what your x and y coordinates are. This is starting to look a little messy. And while you're thinking about that, oh yes, negative radians go in the other direction. And we know this is, I just erased it. This is 3.14, but in this direction, it's -3.14. And if we're going -3, I got a feeling we're in here, that vicinity. Once again, straight up and down. So the y coordinate should be, of course, we're looking downwards, right? -0.14-ish. I know pi is 1.5, so it's got to be smaller than that. There's a little bend there, but what did Google say for the sign? -0.14. 0.1411. Then no 1.5 are the next two decimal places for pi. So yeah, that makes some sense. All right. That it should be about the same as the arc length. And so what's the cosine? Well, the cosine is the width. Right? That's the x value, and sure looks like it's pretty close to -1. So negative 0.99-ish, something like that, is a good guess. And it was, where is it? Negative 0.989. And you don't need a calculator to get some approximations. But if you don't get a feel for what a radian measurement is, you're going to study a whole unit on trigonometry. Not going to mean what it needs to mean. Right? So now, did I give any others? Cosine of 7, sine of 7. So 7 radians. Where's 7 radians going to be? Again, we're back over here to 6.28. So we got to go up 0.72. 0.72 would be about, if that's 1 radian, somewhere in here. And again, we're near a half, a little bit bigger than a half. And we're over here at, the 0.8, 0.9 range for x's. And it turns out that the cosine of -3, which is going to give us this x distance. Oh, no, I'm not doing -3, I'm doing 7. The cosine of 7, right? 6.28, 7, boom, 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 boom. Notice I'm making a triangle now, right? Which has an x and a y and a 1. And that x distance, I wrote it somewhere, 0.75. Okay, so somewhere in this vicinity. And the height was 0.65. 0.65 was the height. So we're in the right ballpark. Certainly in the correct quadrant. Might have a little more meaning as we continue to talk about it. Of course, there are special case situations. Let's do a special case situation right now and lead you towards what we're going to be doing by early next week. And the one I'm going to give you right now is to find the y coordinate at 5 pi over 6 radius lengths. And we're not going to need a calculator for this. We're going to get an exact answer. And I think that's why folks generally start here with most trig classes. I didn't. I started with what a radian is. Okay, what is the sine of 3 radius lengths? We can approximate this. All right, we know pi is 3.14 approximately. And if we divide that by 6, we get 0.5, let's see, 6, so 6 goes into that, 530, roughly 0.52. And if we multiply that by 5, yeah, we got around 2.6-ish radius lengths. The 2.6 radius lengths is going to take us in this vicinity. But as I said, we don't need a calculator for that. So let's show you why we don't need a calculator for that. And you'll get some practice with what conversation we're starting here. We're just starting a conversation, that's all. The practice will come in class. But let's just look at a 3, 4, 5 triangle. This is done in the video, unit circle video. And let's look at an angle. And the cosine of that angle is 3 to 5. The sine of that angle is 4 to 5. And I don't even have to talk about what side is called what. And the tangent, those are the big 3 trig functions, 4 to 3. Yeah, I'm just going to leave that there. You can look at it. All right. So let's look at a triangle that we can figure some things out without a calculator. Equilateral triangle, 60, 60, 60. I am going to cut this triangle in half, which means that I now know the width. We have been practicing this. Some folks are leaving these problems blank. 1/4, 1, which means that this has to be 3/4. And so the length here has to be the square root of 3/4, which is √3/2. And I've been asking you to memorize this. It's approximately 0.86. 0.87, I think, is even closer. Okay, it's on your memorization sheet. And you definitely want to have a feel for this triangle, because we are going to do a lot with it. So there's a 60-degree angle, there's a 30-degree angle, and a 90-degree angle. And we're going to learn the language of trigonometry based on this. Why? We know that 180 degrees is matching up with our new language system as 3.14 radius lengths. Well, 60 degrees, I think a third of that distance. So there's the top 180, and we're going to break it up into 3 chunks. Right, equal size, drop it perpendicular to the x-axis. There's our 60-degree angle, or pi over 3 radius lengths, a little bit more than 1, right? 3.14 divided by 3. So it's a little more than 57 degrees. In fact, we know exactly what that is. It's 60-degree angle. And so what's opposite 30 degrees? Half the hypotenuse. And what is the other side? 1/2 times √3. And √3 is about 1.773, I believe. And I don't expect you to know that just from hearing it once. Conversation has started. So back to the problem at hand. What was it? Sine of 5 pi over 6. By the end of the semester, I'm hoping you're doing a problem like this in your head. And I'm hoping it doesn't take you any more than 10 seconds, max. All right, sine of 5 pi over 6. So I'm just giving you a little look into the future here. I see pi. I see the top half of the circle. I'm breaking it up into 6 parts. It's 1, 2, 3, 4, 5. Oh, this is counting from 0. 1 pi over 6. 2 pi over 6. Oh, what is pi? 180 degrees divided by 6. We're looking at a 30-degree angle. And that's this reference angle right there. But I'm going radian measurement to here. I'm going to draw a triangle. I recognize the hypotenuse is always +1, negative √3 over 2, negative 0.87, 1/2. This is what we're going to start practicing. And I lay it out with the unit circle video. You'll have a chance to practice that. I thought it was more important to talk about what a radian is before we even begin our study of trigonometry. And why? Again, this is a 2-step function. Trigonometry is a 2-step function. And I'm going to do this without pi right now, based on something that I hope resonates with you. All right, did I put the numbers down somewhere? Lost them. All right, so 1975, there were 800 of something, 2024, 700, and it fluctuates, max to min, so on and so forth. These are called sinusoids. They're based on the middle, and the middle is 750. So I'm going to approximate here 750. How do I get it to 800? I got to add 50, and I'm going to do sine function. Right? Because the sine function at 1.57 is a max. So I'm going to write this so that 1975, x minus 1975, plus 1.57 radian lengths. What happens when I put 1975? I get 1.57 radius lengths. And what is the approximate value of the sine of 1.57 radius lengths? Oh, that's the one that's straight up. That's a y value of 1. And 1 times 50 is 50, plus 750 is 800. Matching up. And then when I put 2024 in, so I've got 1975 matches up with 1.57 and 2024. Oh, that's a jump of 49 years. I think we've been practicing how to write the equation of a line, because these radians are going to become our x-axis. Okay. Sure, this is probably going got to start the conversation. All right, now I've got max to min. Max to min. That's 180 degrees. But back again is one rotation. One rotation around is 6.28. Well, that's why I erased this. And we did more than one revolution. We did 2 revolutions and a half. We did 2.5 revolutions of 6.28. Right, so I guess I got to do it now. Did it somewhere, and I got to do it again. 31, 16, 2 times 2, 4, 1 is 5, 12. Looks like I got a 0, a 0, a 6, a 5, and a 1. 15.6, we'll say. So 15.6 is roughly, once around 6.28, another 6.28, a little bit further. 12.56. Just check this real quick. Plus 1.57, 3, 1, 6, 11, 3, 4. I feel like I made a mistake here, but I'm not going to go back and do this video again. So 2.5 revolutions is really what, though? Really, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Oops, where was it? 5 pi. And that's starting from 1.57. That many units. 5 times 3.14, but a whole lot easier doing this, right? 2, 7, 15.7. So 15.7 would have been a better radian approximation. Okay. And, you know, I could have done maximum width as an angle, 0 degrees. So you haven't moved at all. There's no radian. So maximum width, why I wrote 0, there's 1. And that occurs at 0 degrees or 0 radius lengths around the circumference. So I could have written this as 750 plus 50 cosine of 5 pi. I'll write it as whatever I said it was. I can do it again. I'm losing track of everything. Yeah, I think it was 15.7 over 49. X minus 1975. Obviously, you don't have to write 0. So now I've said an awful lot here, and probably not a whole lot of it makes a lot of sense to you hearing it for the first time. But the conversation has to start, and you have to get a little sense of where we're going to go with something. And we're going to do it piece by piece by piece. And we've got ourselves, I think, about 3 months left of study. And if we get the conversation up and running, then I'm hoping, as I say, that if I tell you what is the cosine of negative 19 pi over 3, you'll be able to tell me in 10 seconds or less. You're going to have to work to get there, but many students certainly are able to do that, and I hope you're one of them. All right, hope I said what I wanted to say. A little tired here, but I felt like I had to get this done before you come back from break.